and switch it up a little bit. Now we've got a definite integral. Process pretty much stays the same. Inside, 2x minus 1. Your du would be 2 dx, and this is one of those sneaky ones where I don't have a 2, so 1/2 du is equal to dx, and we don't have that x, so we'll go back up to our u statement and say that x will be equal to u plus 1 divided by 2 when we solve for x. When we go back to rewrite the problem, and this is where things get a little different. We'll rewrite this. I got my integral. It's a definite integral this time. We'll address that in just a moment. When we rewrite the inside, we've got our square root of u. Our x is u plus 1 divided by 2, and the dx is replaced with a du times 1/2. Now, here come the boundaries. Since I put this equal sign here, I need to make sure that I'm saying the same thing. And right now I'm not, because of my definite integral, and I've got an indefinite integral. The thing is, these boundaries, 1 and 5, these are x values. What we're going to do is we're going to change them into u values. And we have a relationship that compares u and x. This statement here, u is equal to 2x plus 1. If x is equal to 1, then u is equal to 2 times 1 minus 1, or 1. If x is equal to 5, then u is equal to 2 times 5 minus 1, or 9. So now I've got an equivalent statement. Alright, so let's go off to work here. This will be equal to, now I look at that u plus 1 divided by 2 divided by square root of u. I know that that u plus 1 divided by 2 is multiplying by 1/2, and I can kick 1/2 out front, so I'd end up with a 1/4. The antiderivative from 1 to 9 of u plus 1 divided by the square root of u du, which I know that I can rewrite. I'm going to come over here to the side. So I got 1/4 times the antiderivative from 1 to 9 of, and this u plus 1 divided by the square root of u, we can do a distribution. U plus 1 divided by the square root of u is the square root of u, or u to the 1/2. 1 divided by the square root of u is u to the negative 1/2 du. Antiderivative, 1/4 u to the 3/2 times 2/3 plus u to the 1/2 divided by 1/2, or multiplied by 2. Now, because this is a definite integral, I don't need the plus c, and I can evaluate this from 1 to 9. Now, the interesting thing about this is you don't have to put that u back in. Because we've changed up the boundaries and everything's been equivalent along the way, we can just go ahead and keep on solving this in terms of u, because we know the boundaries for u. So we've got 1/4 times 2/3 times 9 to the 3/2 power, plus 2 times 9 to the 1/2 power, minus 1/4 times 2/3 times 1 to the 3/2 power, plus 2 times 1 to the 1/2 power. A little bit of cleanup, where we've got 1/4 times 2/3 times 9 to the 3/2. So 9 to the 3/2 is going to be, let's see, the square root of 9 is 3 to the 3rd power is 27. 2/3 times 27 will be 18, plus 9 to the 1/2 will be 3 times 2 will be 6, minus 1/4 times, and inside that quantity, everything to the 1 to the 3/2 and 1 to the 1/2 will just be 1, so we get 2/3 plus 2, which is 2 2/3, or 8/3. Running out of room in my corner here. 18 plus 6, 24, times 1/4 will be 6, minus 1/4 times 8/3 is 2/3. 5 1/3, or 16/3 for a final answer.